Greetings everyone. Here we give few examples of limits that were discussed in our last video. In example 1, we consider the function given below. We want to see the behavior of the above function as x approaches 2 from both left and right sides. That is, we want to find the value of L in the given expression. Now we first approach 2 from the left side. That is, we want to find the value of limit of f of x as x approaches 2 from the left. Now the graph of the function is given below. We give few values of x which are approaching from the left side of 2. Then, we see that f of x is approaching the value 3. Observe the given data carefully. Hence we conclude that the left-hand limit is equal to 3. Similarly, if we approach 2 from the right side, we find that f of x gets closer and closer to 3. That is, the right-hand limit is also 3. Since both the one-sided limits are equal, we have the following conclusion. In example 2, we consider the function f of x equals modulus of x divided by x. We want to find the value of the two-sided limit as x approaches 0. Here, modulus of x is called the absolute value function, which is defined as follows. So, the absolute value function always gives us a non-negative value irrespective of the given input value. So, now we can write the given function as f of x equals 1 when x is greater than 0 and minus 1 when x is less than 0. So, the graph of the function is shown as. Now, we can see that if x approaches 0 from the left, f of x approaches minus 1. And, if x approaches 0 from the right, f of x approaches 1. From the previous observations, we conclude that both the one-sided limits exist, where f of x was given as modulus of x divided by x. Since both the one-sided limits are not equal, we say that limit of f of x as x approaches 0 does not exist. Till now, we have been taking help of graphs and numerical data to find the limits of a given function. But this will not be always possible, since sometimes it will be difficult to sketch the graph of the given function. Also, numerical data may mislead you. And, to see that, we take the function f of x equals sine of pi by x. The numerical data, as x approaches 0 from the left and right side, is shown below. Look at the data carefully. From the above table, we might incorrectly conclude that limit of sine of pi by x as x approaches 0 equals 0. The fact that it is not correct can be observed by the graph of the f shown below. Observe the graph carefully. The graph reveals that the values of f oscillate between minus 1 and 1 with increase in rapidity as x approaches 0 from both sides. Hence, we conclude that the limit in this case does not exist. We saw that the graph of the data has given us an incorrect view that the limit of sine of pi by x as x approaches 0 is equal to 0. The graph has deceived us because the x values selected are all happen to be x-intercepts of f of x. That is, they are the roots of the given function. This points out the need to search for alternative methods to find the limits of a given function. We will see different computational techniques to find the limits of a function. In our next video we will see an important result as shown below. The above limit is considered to be one of the standard limits. We will see why this is true and give different methods to prove it. Thank you.